Hi everyone, good morning. I hope you're able to hear me.
Yes, sir.
Yeah, so from today we are going to talk about a data frame. So this is very, very important. Okay, so in the future, even I'm not going to cover this RDD for the future batches because as data frame is much more important for us and RDD is not that much important. So we can ignore the RDD, but 100% is everyone should practice with data frame. So that is very, very important. So how the Spark is going to work, we already know about it. We already talked about how exactly the Spark is going to work. We'll be having a driver node and worker nodes, right? So basically, when you submit a job or when you submit an application, basically we are going to submit an application. So what happens when you have a application and when you submit this application is going to be executed across the multiple nodes. In general way, you just imagine I have a one box or like I have some work. Just imagine this is some work. I'm having four boxes here. These four boxes having some items. Okay, so box I have six persons. Person one, person two. So like this, I have a six persons. So some items are there in each bucket, each box. Okay, so just imagine some items. I'm a person. I'm just trying to give a work to this person's saying that. So take a boxes and give me what are the number of items are there in the what are the number of items are there in each and every box. So my expectation is how many items are in how many items are there in all the boxes in all the boxes. Okay, so I'm not interested to count it. Okay, I'm a driver. I don't I don't do anything. I'll just assign this work. So I'm saying that this box one, box two, box three, and box four. So box one, I'm giving it to this person. And box two, I'm giving it to this person. Okay. And box four is this person. And box three is to this person. So something like this, I'm just taking randomly. Okay. So if I give all these boxes to one single person, that is what the monolithic approach, right? We discussed about it. So it will take longer time because one person has to count all these things. But if you have a multiple persons like this, multiple workers for you, and if you assign this box one to one person, box two is one person, and different persons if you give, and what he will do, he will take the box one and he will count it. And just imagine he's saying the count is there 10. 10 items are there. And this person is saying 15 is there. And this person is there, he's saying 5 is there. Okay, and this person is saying 20 is there. Okay, so he's going to give his count and he's going to give his count and he's going to give his count. And each and all this four individuals are going to give one, their own count. Okay, so I just wanted to say this two persons are there in one group one, and these two persons are in group two, and these two persons are in group three. So you are doing the count within the same group or within each group, we can call it as a executors. Each group, we can call it as a executor. And this one, we can call as task. Here also we have a task, right? And here also we are giving a task. You're giving a box means you're giving a task to them. Okay, so every task is making a count with some certain part of the data. So this group, this box is the red, this box we can call it as a partition. So some part of the data we are giving it. We are not giving all the data at one shot. This entire thing is a data. Okay, your entire work is this one to get the total items of the count. And you're giving a chunks of the data to each and every individual. So because of that reason, this we can call it as a partition. And since each one is doing some task to count it, so we can say it is a task. And this task is, we can also call it as a JVM. Okay, JVM also we can say, because JVM is going to run on top of this particular person. And we can also say core. Okay, so if number of cores are more, then more parallelism you're going to get it. So if there is a 2 cores, then 2 tasks we can run it. And if there is a 4 core node, okay, so executor, this is entire thing is one node we can say. Okay, so you don't need to worry about all those things in general. So here my intention is I'm just giving some work and they're giving a count each and every individual because we have given this work to 4% and 4 persons are giving. But who will give the total? So 10 plus 5 plus, 15 plus 5 plus 10, 20, 20, 40. So 40 is there, right? So who is going to give this 40? This entire thing. Okay, so one more thing I wanted to say, you're doing the count here. Count when the count is there, you're making a shuffle. You have to count it. Okay. Within the local, you're making a count. Within the executor, we're making a count. But when it comes to here, what happens is you have to take the count from here, 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 and here. So someone is going to make the count. Just imagine this person is going to do that count. Okay, so he's going to say 10 plus 15 plus 5 plus 20. So this is a global count. So we are not doing the count within the same executor or within the same group. We are doing a count out of the box, out of the group we are doing it. Okay, so here we are going to have a more shuffle because data has to move across the nodes. Okay, so when the data is moving across the nodes, what type of transformation it is? It is a Y transformation. Okay, I'll give one more time. I'll just talk about it. You'll get little more clarity about it. So this is how this Spark is going to work. When you give a file to process the data, so driver is going to give the work to the different persons, and you will be having a resource manager. So resource manager is going to allocate the resources to the driver, and driver will give the work to the resources. So if you can give this example, this is much more enough. Okay, so at least if just talk about the 3 minutes, that's more enough if they ask how Spark is going to work. Now I'm just giving each and every individual what they're going to do it. Even if you read out this point, then it is going to help you. So driver basically is the heart of the Spark application. Okay, so driver is the entry point inside your program. Okay, so main function is going to run from the driver. So main is the driver. Okay, so generally we can say when you compare with the Java. So driver here we are going to say Spark session. Not Spark session, I'm sorry. So driver is the entry point that you're going to do it. So it is the heart of the application and it manages the information and state of the executor. If any of the executor or if any of task or executor is not in the what I can say. So if they're not in a position to work, then it is going to give a status. It is going to get the status from each and every executor. So how do you know this particular person is working or this person is working? We don't know is this person having illness or something, right? So in the same way, we're always going to give a status to this person. So executors of the status is going to be managed by your driver. And driver analyzes, distributes, and schedules the work. So first it's going to analyze your work. If you give it some work, so work will be analyzed, and it is going to be distributed also. The work is going to be distributed across the different persons and schedules the work. So this is the roles of your driver. Just have a look on it. And then executor, by name itself, we can understand executor is going to execute something. So it executes the code. Simply whatever the code is there, whatever the code is available. So the code is also going to be converted by your driver only. So the code is going to be kept in all the places. I mean to say JVM is going to kept in all the worker nodes. So then it is going to start it. Okay, so it executes the code, driver executes the code, and the executor, another responsibility is it has to keep update your driver saying that I'm up to date or I'm available. So I'm working on it. You have to give it. Like when you have a lead in your team. So when you're working, if the driver asks the status, what is the status of your work, then we used to give a status. Okay, so that is the driver responsibility to get the status, and as a team member, we are responsible to give the status to the lead also. So that is how it is going to work. And executors are the JVM processors. As I said, the JVMs are going to run inside your task. Okay, so this entire group is going to be executor. Executor can have a multiple tasks, depends on the number of nodes. Depends on the number of cores. Okay, so executor is something you can just feel that the node. Okay, node 1, node 2, something like that. It's like a system. Inside the system, you'll be having a multiple cores. You may have a 4 cores or 8 cores, depends on it. So if you have a more number of cores, then we can have a more number of parallelism. So I'm just giving a task. Each task can work only one partition. As I said, it is going to work only on one partition at one shot. It is not going to work with multiple partitions. So once one task is completed, then it will take another task. I mean to say another set of box. If you have only 2 persons to work as a give, like 4 boxes were there, right? So if you have 2 persons, then what you have to do, you have to give the work to the 2 persons only. So at one shot, you can take only 1 box to work. You cannot work with the multiple boxes at one shot. So once this is completed, then he is going to take another box to count it. So that is how it is going to work. And tasks, as I said, tasks are going to be executed in parallel. If you have a more number of tasks inside the executor, then you will be having more parallelism. Executors are JVM processes running on the cluster. I already told you. An executor hosts the cores, and each core can run one task at one shot. Okay, so executor is going to host the course, or course means your tasks. So task is going to run only on particular partition. You cannot run more than one partition. So most of you already know about the partition. So partition means like I have some major work. I'm just going to break this into pieces. Break into pieces. So multiple pieces will be there. So that is a partition. Okay, so partition, why we need to have is if you wanted to do the parallel processing, then definitely we require partitioning. So if you don't have a partitioning, then you are not going to get the performance. So that is how the traditional system works without partitioning. Okay, but when it comes to the Spark is always going to do the processing by partitioning. Okay, so by default, it is going to have a capability to partition the data, and you can also increase or decrease, depends on your requirement. So partition, it allows executors. It allows every executor. Every executor can have a multiple tasks, right? One executor can have a 4 tasks also. If they have a 4 cores, then there will be 4 tasks can run parallelly. Or if there is a 8 8 cores, then there will be 8 tasks can run parallelly. Okay, so to allow every executor to work together in parallel. So it is going to work to allow them to work parallel. The Spark breaks down the data into chunks. So as I said, when you have a employee.txt, employee.txt is not going to sit in one place. Okay, so even in the storage also we talked about at the time of Azure Data Lake Storage N2. So at the time of processing also is not going to process in a single machine. This data is going to be divided into multiple pieces called partition. So here we are going to call this as a partition, and in the ADLS we are going to call the same thing as a blocks. Multiple blocks we used to call it as. So blocks are nothing but partitions. We already know about it. So why we are making this block is to increase the parallelism. Okay, so to increase the parallelism, we are going to take it. So that is how even the Spark is going to divide your work into multiple pieces, and multiple pieces are going to be distributed across the executors to make it parallel more and more. So that is about the partition. So the intention of this Spark is to do the transformation, right? We already know about it. As part of RDD, we came across more in detail about the transformation. So transformation means it's a process of shaping the data. You're trying to save the data as per your business requirement. Okay, so in order to save the data, you have to run some code. Okay, so we can call it as a code or a data pipeline, people used to call, or instructions, anything it is. You're giving something, you're giving some order, do this, save, do that, do this, or something like that. So that we can call it as a transformation. The process of shaping the data is known as a transformation. So the instructions are the code to modify and transforms the data is known as a transformation. Or simply we can say the process of shaping your data with the data pipeline, we can call it as a transformation. So data pipeline can be by ADF or by ADB also. It's a generic term. Transformation is a generic term. And transformation will help in building the logical plan. So basically Spark is going to build the logical plan. It is going to build the logical plan. So when it is building the logical plan, on what basis it is going to build? So based on the transformation, your Spark is going to create a logical plan. The Spark is going to create a logical plan. So let me take an example. I have an employee data. Employee.txt. Even in the RDD also we used it. So I wanted to transform. Here we have a various departments here. I wanted to apply a filter. To get some specific data. Let's say there are many people are getting salary. I wanted to say salary greater than 2000. So that is the condition I wanted to do it. Then what you are going to do is you are going to say salary greater than 2000 here. Then output you are going to get it. Output you are going to get, I'm just saying employee data. So this employee data is having only if the salary is greater than 2000. So this salary greater than 2000 is a transformation. You're transforming the data. So from here, I just wanted to take only, I wanted to apply one more transformation here. If you remember, we have seen single group by single aggregation, right? So if you wanted to do my final target is something like this. DPT number and salary. So this is my final target. And I have taken only, again, here the salary, the employee salary greater than 2000 only. After applying that, I wanted to take only DPIT number wise total salary I wanted to set. So here also you are going to get some employee data. Oh my God. This is not. Is someone controlling me? Something happened. Okay. No worries. So some employee data is getting. So here I wanted to take, I need only two columns only, right? So just select DPT number, comma, salary. Only these two columns only, I wanted to take it. So this is also is a transformation only. Guys, is anyone controlling?
Oh, no, sir.
No, right? Okay. Because it is,
I think you can reshare the screen, sir.
no, not resale. This is not related to resale. Okay. So here I'm having it, and later I'm going to apply. My final target is here also you're going to get employee data. But in this particular place, I'm just going to take a data aggregation. Okay, so I have a various transformations here. Here is one transformation, and here is one transformation, and here is one transformation. So if you observe here, this transformation is going to apply on each and every partition. Let's say, for example, I have a 8 node, not 8 node, let's say 4 groups are there. So the group 1 is having 2 tasks. Let's take a 6 only because of the space. So this is executor 1, executor 2, and executor 3. Okay. And here I'm having, this is task 1. So your block 1, just imagine I have a 4 blocks. 4 blocks of the data is there. So that means block 1 will come to here. Block 1 is here. Block 2, block 3, and block 4. Okay, so what it is going to do is first transformation. When the first transformation is applied, my data is not there in a single place. My data is there in all the different places, right? Because I have a 4 partitions data. So 4 partitions I have given to 4 different tasks, and each task is going to work together parallelly. Okay, so first transformation I'm giving it sales greater than 2000. So employee data is available here. Here also it is going to apply sales greater than 2000. This person also is going to apply same rule. This person also is going to apply same rule. That means all the 4 different tasks. This is a task 1. Let's say task 2, task 3, and task 4. 4 tasks are going to work together parallelly to apply their own, to apply transformation on their own data. Okay, so that means they're not sharing data across the different nodes. So within the same place, it is applying the filter. So that we can call it as a narrow transformations. What type of transformation it is? Narrow transformation. So narrow transformation means within the same partition, the data is going to be filtered. So task one is going to apply a filter on its own partition data. And here also I'm just taking what you're trying to take it and just wanted to take the department number and salary. I have a too many, all the columns. Let's say your employee table is having 10 columns. So 10 columns are there in the task one, 10 columns are there in task two. In all the places we have a 10 columns. But what you're expecting, I need only two columns. I don't need other columns. So this is the second transformation. The second transformation is also it's going to apply within the same partition, not with other partitions. So I mean to say task one will apply transformation on its own partition data. So this is also is a narrow transformation. Next we are doing data aggregation. So data aggregation means this data aggregation by department number. Now tell me department number 10 is available here. 20 is available, 30 is available. Here also same. 10 is available, 20 is available, 30 is available. Here also same. Let's say 10 and 20. And here 20 and 30 is available. Just imagine. Now, if you wanted to apply aggregation, if you wanted to say, then definitely what you have to do? You have to bring the data from the B1 and you have to take the data from B2, B3 and B4. In all the places, from all the four different tasks, you have to take it. Four different tasks, you have to, from four different tasks, you have to collect the data. So that means the data is moving between the partitions. Data is moving between the nodes. So when the data is moving between the partitions or when the data is moving between the nodes, that we can call it as a wide transformations. Data is going outside. Data is going outside. So we are calling that as a wide transformation. You got my point, right? The same thing even in the RDD also. You can apply the same thing in the RDD. There also we have seen how we can apply a filter. There also we have seen how we can take only required columns with the key value pair. And there also we have seen the data aggregation with reduced by key. The same to same here. Is everyone with me?
Yes, sir.
Okay. Now depends on this particular transformation, depends on the list of transformation. The Spark is going to create a logical plan. Okay, so first what you have to do is going to be decided. Okay, the flow of execution is known as a logical plan or DAG, direct acyclic graph. Okay, now let me move on. So this is about how exactly the logical plan is going to be created behind the scene. These transformations will help to create a logical plan. Okay, so we'll see that how exactly the logical plan practically we are going to see when we apply the transformations. So that is what I have given here also. Employee, just apply the filter, select aggregation and final result. This entire thing, this entire process, we can call it as a logical plan. Somewhere it is holding it. Just give me 1 minute. The next is, we already know about these actions. You can just still, I'm having some issue. I just reconnected it. Let's see. So actions, we already come across it. Actions will be used to trigger your transformation. You're already having transformations. Let's say, for example, filter is there. You have seen filter, select, and aggregation is available. And final result. If you wanted to get this final result, you have to say action. So then only you are going to get the final result. So these three triggers, these three transformations will be triggered by using the action only. So until unless you say action, the transformations are not going to be executed. The transformations are going to be lazy. So actions will be used to trigger the execution, and we need to call an action. Action basically executes the plan which is created by transformation. Okay, so the logical plan will be there, right? The logical plan is going to be executed when the moment you call that action. So there are three different ways of actions, or there are three types of actions we're having. One is to console, to view the data in the console. We already seen, if you remember, rdd.collect. You're seeing the data within the console only, right? So that is one type of action. Another is collect the data to the native languages. That means you can store this data into the different native. I mean to say, native means when you write a Python, then it is a native. If you write a scalar, then it is a scalar is the native language. So we can bring that entire data into the native also. That is possible. Okay, so we can store in the local objects and we can use that. And very, very important for us is the first, this one and this one. The second one is not much important. So the first one, why it is important is because we have to see the data. While doing the development, we have to see. Otherwise, we cannot understand how data is available. So to make us understand, it is going to help you more and more at the time of development. But in the real time, after completion of your development, at the end of the day, you have to write the data to the target sources. Your target may be anything. Okay, so how we can write the data into the target, we are going to see that. And lazy evaluation is one more term. It is very important for interview point of view. So they will ask, what do you mean by lazy evaluation? We have seen this transformations, right? These transformations are lazy. They will not execute by their own. They are transformation. Their transformations are not going to execute by their own. Someone has to call them. Someone has to trigger them. That someone is the action. So that till that it is going to be hold. Okay, so after completion of the transformation, the logical plan will be created and the logical plan will be executed by your executors. So Spark will wait till last moment. This is not fill, it is a till last moment to execute the graph of computation. So graph of computation means this is how it is going to execute it. Okay, so internally it is going to generate the DAG, a direct acyclic graph. This direct acyclic graph is going to be executed. So till that it is going to wait. Your Spark is going to wait. So you're making them to wait, right? So because they are very lazy. To allow Spark to optimize, why it is going to wait? Why the importance of this lazy is, if you say can go and do this work, they will not do it. They will collect all the work from you. You just imagine you are a owner of some work and you have given to the different persons, and they will take all the requirements from you first. Based on the requirement, once they understand the requirement, they will start thinking like which one need to start first and which one need to start next. So that is what the plan of execution. The plan of execution is nothing but a DAG. Okay, so they're still waiting, right? They're not working. they're not working. Instead of working, they're just waiting to understand the requirement, to understand the transformations. Okay, so because of that, we can say it is a lazy evaluation. They're going to wait till the last moment. Till the last moment, what till what time? Till you call the action, they're going to wait. Then they're going to start execution. Okay, so it allows Spark to optimize. Why we are going to use this lazy evaluation is to optimize your performance. To optimize your performance, we're using. So the Spark is going to optimize, plan, and use the resources properly for your execution. Okay, so this is very, very important. So traditional systems will not wait till you call the action. So once you have given a transformation, they're just going to do it. Okay, so that sometimes very starting of the time that was fine, but later when the data grows exponentially, then that was not fine. So because of that reason, this process came into the picture. It's a lazy evaluation. And the next thing, very important term is Spark session. Definitely in the interview, they're going to ask, what is a Spark session? How can you create a Spark session? How can you create a Spark session? They're going to ask. Okay, so Spark session basically when you come for the data bricks, when you come for the data bricks, by default you're going to have a Spark. Okay, and even when you go for what we can say that is command prompt, Spark command prompt, Apache Spark command prompt also is going to have a Spark session by default. Okay, and this two we don't have any problem. But when you go for when you go for what is that IDs like visual code and PyCharm, something like this, we have a different IDs. Okay, so those IDs will expect Spark session because they're not part of the data. They're not part of the like they are not built by default. They are not kept for Spark session because these are built for different purpose also, not only for Spark. So whoever is going to work something, even if you wanted to work with some other code, we can also work with that. But when it comes to here, this Databricks is specifically designed for only Spark. So because of that reason, when you come for Databricks, the Spark is going to be available. You can see the Spark dot function. Okay, so Spark dot create data frame. We are going to see that. Without this variable, we can start it. So Spark session is nothing but a variable. Okay, so the driver process or driver program is known as a Spark session. So it's the entry point of your Spark execution. If you wanted to go for execution, then it has to go for Spark session. Without Spark session, we cannot do it. The Spark session instances executes the code in the cluster, and for every Spark application, there will be one Spark session. So if you are submitting one application, one work, then one work means one notebook. In this case, we can say it is one notebook. For that notebook, you are going to have a Spark session. And how we are going to create a Spark session in the interview, some people will ask. Okay, so you can say that I work with the extensively with the Databricks. So the Databricks by default, it supports to have a Spark session. We don't need to create a explicitly a Spark session. We can say that. Okay, but still the people are going to ask. So if they ask, then you have to, I've given the note here. So the Spark session, you need to import from the Spark SQL. You need to import it. So from pyspark.sql.import Spark session, you have to take it. And then you have to create it. Spark equals to is a variable. Spark session dot builder dot app name. You can give any app name here, anything that you can give it. You can just remember this one. If they ask in the interview, you can give it by using the Spark session. We can create a Spark session. So Spark session.builder.app name, where we need to provide the app name. And then you can give a master and the node name you can provide, or you can use get or create is going to be created this particular Spark session. So this you need to remember it if you wanted to go for other than the Databricks. So only in the Databricks you can have it by default. You don't need to worry about it. When the moment a cluster is started, your Spark session is going to get it. That note also I have given here. If you are working with Databricks, we don't need to create a Spark session. By default, it will be taken care by Databricks itself. Is everyone clear?
Yes.
Now we are going to see the data frame. So what do you mean by this data frame? Wait a moment. So what do you mean by data frame? It is a distributed collection of data organized into names and columns, or named columns, we can say. Okay, so it is similar to your relational database tables. Relational database tables. Like we have seen SQL, right? In SQL, we have a data, even with the data factor also, we have seen how our data is going to be there. So it is going to be distributed. The data is going to be distributed. Your RDD also distributed, and your data frame is also distributed only. So it is a distributed collection of data organized into columns like a tables in the relational databases. Okay. And if you wanted to create a data frame, we know that data frame is going to be used in order to handle the structured data. So if you have a structured data and semi-structured data, we can use this data frame. Now we need to know how we can create this data frame. In order to create a data frame, we have various options are available. The first one I'm going to talk about is Spark.create data frame is one of the function that is available in the Spark session. Once the Spark session is created, within the Spark session, we can find the function called create data frame function. Using that, we can create a data frame. So when you use this data frame function, when you use this create data frame function, it is asking to pass the local object or RDD. So we can use the local object to create a data frame, or we can use the RDD resilient distributed data set to create the data frame. And we need to make sure to pass the schema for that particular data frame. So what happens if you don't pass the schema? We'll see. And what happens when you pass the schema to this particular data frame? We are going to see that. So it is used to create a data frame by taking the data from the local object and RDD. We are going to see that practically, how exactly we can do it. And the second approach is Spark.read. So data frame reader, by using the data frame reader, we are going to do it. By using a data frame reader, we can create a data frames. This is very, very, very important. 90% of the time we are going to use only this. Okay, so in my project, I used 100%. Okay, so it is used to basically the Spark.read is going to give the Spark is the Spark session. It is an entry point, right? Within the same place, within the same object, we are having a function called read function. So this read function, the responsibility of this read function is to create a data frame reader. We are going to get the data frame reader. We are going to get the data frame reader. So it is used to get the data frame reader, and data frame reader, once you get the data frame reader, within the data frame reader, we have the following functions. So I'll show you where exactly you can have these functions. Just observe. You can see it. These are all the data frame reader functions. Before that, there is a spark.read. Let's see this one. Let's go to the API documentation. From here, we can do, I guess. Data frame, not this one. Okay, anyhow, you can say here. So PySpark.SQL.data frame reader. So how you're going to get this data frame reader? You're going to get this data frame reader by using spark.read. So when you use the spark.read, then you're going to get the data frame reader. So this data frame reader, what it is saying, interfaces used to load a data frame from external storages. So data frame reader is used to read the data from the external sources, external source systems. So for that reason, we are going to use it, right? Now you can see the various functions here. CSV is there to read the data from the CSV file, and we'll come to this format. JDBC is there to read the data from the database, and JSON is there to read the data from JSON file. And load, we need to specify the path of it. Okay, so various options, and Parquet is to read the data from the Parquet files. Schema is also is part of your data frame reader, and schema is going to help you to specify the schema for your input data, and table name to specify the table name, and text path, and paths we can specify. So all these things are the data frame reader functions. So that is what I just listed all these functions here. All the functions I listed, so you don't need to search anywhere. So spark.read, it is used to get data frame reader, and data frame reader is having all these functions. So spark.read.csv, what is the purpose of this? It is used to read the data from CSV files. And spark.read.parquet, if you want to read the data from the Parquet file, then you can use the spark.read.parquet. And spark.read.json to read the data from the JSON file, and spark.read.orc to read the data from ORC files, and spark.read.table to read the data from the table. Table, when I say table, it is going to be a database. And spark.read.format is used to read the data of various file extensions. So one single function can read the data from CSV, Parquet, JSON, ORC. Only thing is it is going to ask you to specify the extension of the file if you use the format. We use this function only at the time of working, but you can also use if you have a, if you wanted to use, no one will stop to use these functions also. Okay, and spark.read.load. Load is there here. It is used to load the data from the source data frame, from source to data frame. Okay, so if I wanted to read the data from the CSV file, then you have to specify this. When you use this format function is used to specify what type of format you wanted to load. When you use this format function, 100% you have to use the load function. Okay, you have to use the load function. Otherwise, it is not going to be possible to read it. So simply, I wanted to say all these functions will be used to create a data frame. Simply, it is going to allow us to create a data frame. Now, I'm just going to take the first task, a simple task. I'm going to take it here. The task one is saying create a data frame with local object. When I say local object means it is a Python object. Since we are using the PySpark, then we can say Python object. Okay, if it is a scalar, then we are going to say it is a scalar object. Now let me say here list equals to, list is a Python object. So here I'm just saying 101 Bhaskar, comma 102 Raja. So something like this I have. Let me take salary is 1000, salary is 2000. So I'm having this. So what type of data it is? What is the type of object? Can anyone give the answer? What is the type of object? It's the list only, right? If you have a square braces, then we can say it is a list. List is having what? This is a tuple 1. This is a tuple 2. So tuples are there. So collection of tuples is there inside the list. Okay, so if you have a list, if I wanted to create a data frame, I wanted to say something like name, ID, name, and salary I wanted to get it. So if that is the case, then your output is going to get something like this. 101, Bhaskar, 1000, 102, Raja, 2000. In the grid, I wanted to see. In the grid format, I wanted to see it. So this is what it is, a table. So data frame also is similar. Okay, so not exactly 100% is your SQL Server table, but you can feel that is a table. Let me show you. What I have to do is df equals to spark dot, before that, you just observe when I say spark, the spark session was already there. We don't need to create from our side. So spark UI is created. Okay, I'm just going to say, if I open this spark UI, so we are creating this data frame, SQL data frame, right? If you see, I don't have anything here. Now let me create this one, spark dot create data frame list, comma list. I'm just giving, just observe what happens. Just execute this and refresh this one. So you are not having anything. Now what I'll do is, I'm just going to display. Display is an action. Display is an action to show the data in the console. Let's execute now. Display. Now you can see, right? If you observe, refresh it. Now you can see one task is created. And even if you go and see the jobs, the job is created. Okay, how many jobs are there? Okay, we'll see that. Okay, so this is too early to talk about all these things. So 3 Spark jobs are created. Spark job 1, job 2, job 3. So 3 jobs are created. And because of that reason, you can see here 3, 0, 1, 0, 2, 0, 3. So 3 jobs, and jobs will be divided into stages, and stages will be divided into tasks. You can see here. One job, if I go here, there is only one stage. Okay, so we'll see, we are going to discuss about that over the period of time. So here, I just wanted to get the schema for this. And how we can get the schema for that also, I guess there is a task. We'll see how we can provide the schema to that. If I'm correct, if it is not available, I'll show you how we can we can give the schema for the existed data frame itself. So I'm stopping here. If you have any question, you can ask me. Okay, then we'll see you tomorrow.